Now that you're familiar with soldering tools, solder types, and fluxes, let's discuss the nuts and bolts of how to hand solder through-hole components onto printed circuit boards. Regardless of whether you're using tin lead or lead-free solder, the hand soldering process should always begin by preparing or tinning the tip of the soldering iron. We explained earlier how oxidation forms on the surfaces of the metals to be soldered. This oxidation will also form on the tip of your soldering iron. Oxidation acts as a barrier or an insulator, which means that it can slow down the transfer of heat. An oxidized tip will prevent the rapid transfer of heat into the metals to be soldered. Lead-free solder is even more sensitive to an oxidized tip than tin lead solder. Notice the time difference between the properly tinned tip and an oxidized tip, melting a similar solder connection. To begin the tinning process, we'll take the hot soldering iron and wipe the tip 2 or 3 times across a damp sponge. This will remove impurities and oxidation, but it shouldn't cool the tip too much. If the tip is wiped excessively, or if the sponge is too wet, the tip could become too cold to use for soldering or tinning. Now let's apply some flux cord solder onto the tip. The flux inside the solder will flow first and chemically remove the oxides from the tip. Then the solder will flow over the tip and form a shiny coating. This tip is now properly tinned. Tinning is especially important on brand new soldering iron tips. Every time you install a new tip, it's important to tin it right away, or it may become untinnable and unusable. Tinning should be repeated as often as necessary. Whenever you can see that the tip is no longer clean and shiny, you've waited too long to retin. Heat can cause soldering iron tips to become so oxidized that they become unusable. It's a good practice to melt some solder onto the tip whenever you plan to let the iron sit for any length of time. This solder coating will keep oxygen from reaching the metal tip to protect it from severe oxidation. It's also a good practice to turn the iron off when it won't be used for an extended period. Some soldering stations will do this automatically. On some irons, oxidation can also form inside the barrel, which is the area between the tip and the heating element. If it's not removed, the oxidation in the barrel can also slow the transfer of heat to the tip and keep it from quickly reaching the soldering temperature. After we've prepared the tip of the soldering iron, we should be ready to start the soldering operation. We'll be using a temperature-controlled soldering iron with a chisel tip. The temperature of the tip will be set at 315 degrees C or 600 degrees F for tin lead solder, and about 350 degrees C or 662 degrees F for lead-free solder. Our tin lead solder will be 6337 eutectic with a 0.5 millimeter diameter. Lead-free solder will be SAC 305 with a 0.79 millimeter diameter. The flux in the core of the tin lead solder will be type L, or mildly activated. For lead-free, we'll be using type M, or medium activated flux. To demonstrate the basic technique, we'll be soldering a round component lead into a plated through hole. To hold the component in place, the leads are typically clinched at a 45-degree angle in the direction of the conductor trace. The leads are then cut off to a sufficient length to ensure visibility in the solder connection. Let's start with tin lead solder. Normally, this type of soldering operation would only take a few seconds to complete, but we'll be stopping the process in order to explain everything that happens as we go along. We begin by gently placing the cleaned and tinned soldering iron tip against the lead and the land. This will transfer heat into both of these parts. Now the solder wire should quickly touch the tip of the iron to melt just enough solder and flux to form a heat bridge between the metals. Then we'll move the solder wire over to the opposite side of the joint, still touching both the lead and the land. When there's enough solder melted into the connection, touch the solder wire to the tip of the cut lead to cover the exposed basis metal. The solder wire is then removed, followed by the soldering iron tip. At this point, it's important to clean the connection if required. Then, we'll inspect the joint to make sure it looks right. A preferred or target connection is where all of the metals are covered by solder and the outline of the lead remains visible within the solder connection. Now we'll demonstrate the same soldering technique using lead-free solder. The main difference is that lead-free has a higher melting temperature than tin lead. So instead of a starting temperature of 315 degrees C, we'll set the temperature at 350 degrees C. Let's watch the soldering operation. Again, we clean the connection if required. The same inspection criteria will be used to determine a target solder joint. However, notice that the tin-silver-copper alloy is grainier in appearance than the tin-lead solder joint. This graininess is caused by the higher melting temperatures and is considered to be only a cosmetic issue. Let's review the soldering process once more to highlight some of the problems to avoid during hand soldering, regardless of whether you're using tin lead or lead-free solder. The tip should lightly contact both parts to be soldered. Pressing down firmly with the tip will not transfer the heat faster, but it may damage the land or the base material. Only a small amount of solder should be melted against the tip of the iron. If you melt all the solder by touching it directly to the tip, you may not get enough solder to flow onto the other side of the connection. Remember that solder flows toward the heat, flux flows away. Another problem is melting too much or too little solder into the connection. If you don't remove the solder wire at the right time, you could end up with something that looks like this. This time we removed the tip before the solder wire. Now we'll have to reheat the joint in order to remove the solder wire. Notice what happens when we reheat a tin lead solder joint? It doesn't look as smooth or as shiny as it was before. Now let's see what happens when you reheat the same solder joint using flux. In this case, the solder appears as smooth as it did before. Whenever you melt solder, you always need to add flux, either through the core of the solder wire or with an external applicator. Now let's look at the correct technique one more time. There is a lot happening in just a few seconds. The parts to be soldered are heated, cleaned by the flux, and joined together to form a physical and electrical connection.